So welcome back. Let's take a look at this new kit. I think the packaging, Sarah's been tweaking the packaging to try to ensure the best survival rate since he ships these all over the world. Open this thing up and see what magic awaits us. What kind of interesting fusion of art and engineering might be happening. Oh, this is the Cordwood Puzzle. I've been looking forward to this one. This is a really interesting kit. And I think this is a puzzle because it's not got instructions. I know a little bit about this. It's modeled after kind of cordwood assembly style that I believe was first used or maybe was popularized by NASA to get just a really high density of analog circuitry and maybe very old digital circuitry into equipment racks that were designed to fly, really getting as much three-dimensional utility out of the space as possible by not just putting components on the board. You can tell it's electronic and it looks like it should work, but just doesn't in any way look like a normal circuit board. So we've got some of these beautiful resistors. So we have these two boards, which look similar. Yeah, it looks like they're the same. So part of why these boards look so interesting is he designs these using his own software that lets him do all of the work in illustration tools like Inkscape instead of using traditional PCB design software. So he can just draw these traces using vector software, but he still has a Python script that handles the kind of manufacturing details like the spacing between the solder mask and the pads and the clearance around the holes and things like that. Oh man, that trace is great. That's really nice. All these little polyhedral pads, they remind me a lot of a feature that you would see on more traditionally designed circuit boards called copper thieving pads. And so the connectors we've got are interesting too. We've got these two pins over here which seem to have a couple of different forms they can take. Well, these seem to be for cordwood style components sticking out, but then this looks like it could either be a surface mount or a through-hole kind of wire harness kind of connector. Maybe a mounting post, and then over here a similar kind of connector, but with more pins. All right, so the other thing that made this kit really so picturesque is just these amazing giant resistors and LEDs. Oh, and is this special wire? Oh yeah, okay, so now we've got standoffs for the giant holes there, which are nice. So mechanically separating these two boards, and they're about the same length, a little longer than the resistors. And we've got these enormous, beautiful LEDs. 105, so I think that's a 0.1 microfarad capacitor. Yeah, some nice little screws. Good flat profile. Yeah, this kit has a really interesting aesthetic to it. Looks like, I haven't looked at all the transistors so far, but the ones I've seen so far are 2N7000, which is like a really garden variety MOSFET with more laser engraving. Got some buddies here. 6 transistors here, and 6 total locations for transistors. Small signal MOSFET. So the flat side facing you, it's source gate drain. These are N-channel, which means that the typical way you'd wire these is with source connected to ground, gate connected to a roughly logic level control signal, and then drain is what gets pulled toward ground whenever the MOSFET is switched on. So each of these boards has 3 transistors. So far, this trace on the left has just been a common source for all the transistors, and that goes here. So it would make sense for this to be like a negative battery terminal. Let's see, what if this is positive battery? Whee! All the way around here. So those will connect vertically through a bunch of resistors to the other board. Those resistors will end up in parallel, and you'll be joining the positive rail of this board kind of loosely with the positive rail of the other board. Unless you flip the two so that this is going to this on the other board, that might make more sense. If the two are flipped relative to each other, this one's connected to that on the other board via a resistor, and this is an LED. So that presumably would be the positive side of the LED, and that would be some resistor to limit its current. And then that LED would be pulled down to ground through this transistor when the transistor is on. And so what turns on the transistor? Well, this would be pulled up through a resistor from the opposite side. And then where else does that go? It's also connected over here. So it looks like what happens is when you put two of these together, kind of reversed 180 degrees, so they cross over when they're with resistors, then you connect power to either board and they both light up, but then you can ground these pads, well, not those pads, these pads here. Oh, gotcha. And if you connect wires through here, connecting the boards, then assuming those aren't connected on the other side, yeah, so that's what this is for. If you connect wires through, then when you just power it on this side, and in fact, these could just be for through wires if we're following the pattern here. So if these are just for wires connecting the two sides together, then these could also just be for wires, and now you're not relying on the resistors to connect the positive rails, which makes sense. So I don't know what these two pins are for. You know, by default, these lights would all be on, but you could ground these inputs to turn them off or connect them to a microcontroller, and this would be a logic level display. Well, I guess it would make sense to start out by putting, you know, all the kind of non-Cordwood style components on, so like the transistors definitely, and probably the LEDs too. I might do these a little bit strangely just so that I can get the best placement, just for, you know, silly aesthetic reasons, because these are, you know, these kits are so much about aesthetics that I can't help but be a lot about aesthetics when I'm putting them together. What is this, 10 ohms and 10K? So I think to get the best placement on these transistors, I might get them lined up while I have the circuit board in the vise, and then actually solder the top sides, and then clip the bottom side so that only a little bit is sticking out, and then do a solder dome that covers up the end of the leads so that it's nice and smooth on that side. A little bit of solder wicked through there, but for the most part I haven't soldered this side yet. My intention is now to cut them pretty close to flat and then give them little solder domes. So I'm trying to give it a little bit of clearance there, because if I cut it just completely flush before soldering it, then the surface tension will kind of prevent it from being a good solder. Oh man, these are not going to produce nice little domes unless I add flux, so I'm going to do that even though I'm going to have to clean the flux off. I'm still getting kind of this matte finish. I think that might just be the solder is still sinking into the hole as it's cooling, because I don't necessarily want a huge amount of it to wick up. So that's fine. I'm not going to worry too much about the finish as long as they have a smooth shape and they won't snag stuff. I've been working on all this, I don't know, stuff that's like, where you can like tell that you're making progress, but not in a way that's really satisfying. And I think that's part of why I thought putting together a kit would be nice. I think that's a common feeling in the technical pursuits. You're always fighting against realities that you haven't quite got your head around. So I think this is the goal. I think the transistors want to be on the inside so that they're kind of protected. And then the resistors show up around here. And then I think you want the LEDs pointing outward. I know there are pictures I could look at for how this is supposed to be assembled, but I feel like that's cheating all of a sudden. Oh, this is labeled with plus and minus on this side, which I didn't see before. Yeah, that matches the reverse engineering. But then if you mirror it like that, then I think that means that the plus and minus aren't right. Yeah, so if you flip it, then plus is on the left, so... Oh! Yeah, maybe this is part of the puzzle. And I still haven't figured out what these other two holes, that one and that one, are for. Like, I don't know if those are wires or resistors. Oh yeah, and there's also a capacitor. We have one power connector and one data connector. Both of them are these surface mount style headers. I'm assuming that we're just going to pick one of these boards kind of arbitrarily to have the connectors on it, and then the signal gets passed through to the other board. Ah, that's a very satisfying flow. So I guess on one of these, the text will be kind of covered up by the connector, and on the other one it won't be. So maybe that influences which one goes on top. Just noticing the detail on these traces going under those little silkscreen shapes. I really like that. And the transistors could be facing inward like that. I mean, if they're facing outward, then the LEDs facing outward maybe make more sense, even though the whole thing is a little bit more exposed. But then more of the artwork in here is visible. So maybe that's nice. Maybe that's how I do it. Because there is all of this writing like on the edge here that is meant to be seen for sure. And the transistors were definitely meant to go on this side. So let's assume the transistors are maybe supposed to stick out. If all of that is correct, then we have to find some way for the power to work out on this side. Yeah, see, I'm guessing that maybe those pads are just intended to be an alternate footprint for that connector, because they look really close to that standoff. But, I mean, it's the same way on that side, so they could be wires. Like, I could imagine wires there, but maybe not a component. Yeah, maybe this is just intended to be two wires crossing, because that looks like it could fit there just fine. And then maybe there is room for a capacitor here. Or maybe the capacitor goes... I don't know where else the capacitor could go. I mean, this doesn't really need the capacitor, but I could imagine it maybe being useful if you were trying to do like high-speed LED pulse width modulation. Really nice looking. So I think that code is 151, so I think that's 150 ohms, but we'll double check with the meter. And then this one here is brown, black, orange. I think that's orange. So I think that's 10K, but let's check that out too. 10K. Great, so these are our pull-up resistors, the blue ones. And then our nice LED current limiting resistors are 150-ish. I don't like this glue stuff, and so sometimes I cut it to avoid the glue, but in this case I'm also going to cut it to avoid bending the leads, because I like how unbent they are right now, and that would be nice to preserve. This first one's a logic pull-up, and then this next one here goes to an LED. And then logic pull-up. So I guess they're alternating on each side. That would make more sense. I imagine, okay, now that I'm doing this, I have to imagine there were some interesting jigs that people developed for getting kind of cordwood style circuits built. Like something you could put all the boards in, or all the components in, and it would kind of line them all up, or like give you at least like a place to put them while you brought the boards in. Okay, so that's all of them on this side. Let's populate the resistors on the correspondingly meshing side of the other board, since that's where we can actually tell which one goes where. There's the 10K resistor pull-up, and then the LED current limiting resistor, 150 ohms, and then 10K, 150, and so on. Let's make them consistent and have the gold stripe toward VCC on both sides. But, oh man, the chemical plating on a typical manufactured PCB is so nice. It would be interesting to try to do that at home. All these little flag things sticking out. All right, so all the resistors are in, the capacitor's in. I think all that's left is the wire, and then actually putting the two pieces together. Oh, and the LEDs, of course. So actually, I probably should have done that even before putting the resistors on, but this will be fine. The lead to the left is our anode with the shorter leg, with a shorter lead frame inside and the longer leg. Yeah. That goes to the resistor, then the other side's going to this transistor switch. So I can choose the order and how I mechanically position them. I've got red, yellow, and green. Does red go in the middle, maybe? It's like the most, like, bold kind of, I'm here, I'm a color, look at me. I kind of like yellow on the left. I feel like people are probably going to want this to be a traffic light. There's something really satisfying about those those LEDs just sitting on the board like that. So let's do that. In that case, I don't really need the vise. I'm just gonna, what do you call this? Blue tack, I guess I've heard people call it. I can just gently bend those leads out while putting a little pressure on it. Because if I just put some of this on my work surface and stick the LEDs down, then I think I can get them flat. Let's try that. Definitely would have been easier to do with the LEDs fully installed before even attempting the resistors. I'm gonna go back over these to get a good finish and a better mechanical joint. Still getting a dull finish. I'm not quite sure why, but maybe something about this solder. I think I want them to be symmetric. I could make them like anti-symmetric, but I think I want them to be symmetric on this one, just because I think that would be nice. All right, so we got our LEDs all looking nice. Okay, I'm glad I put those flush against the board, because that looks and feels much nicer than if they were wobbly. Yeah, actually, maybe the wires are easier after just assembling these two pieces. I think that's the case. I think even the diagonal ones, the wires are easier to put in after. I'm just trying to find, it sort of reminds me of doing something with like tents or something, like trying to find out which pole is longest and then maneuver it into place. And you can kind of control these remotely from the other end like a foosball table. Oh, hey Tuco, you're standing up. How's your nap, little guy? This screwdriver is too small. Whoa, that's cool. A comment from Sodium in chat just found a NASA document entitled "A Fast and Economical Technique for Welded Cordwood Electronic Module Fabrication." I really like circuit board standoffs. They make me so happy, like having boards fit together into a module. Like that's how you know you've made it. It's not like having a plastic enclosure or having your thing like in people's hands. It's having standoffs on your circuit board. That's totally going pro. Well, I mean, I could put tape on the wire just like I'm doing with the components, but I think at this point it's easier just to solder one side and then clip the other. So I'm just gonna go ahead and get to doing that. Let's solder the first wire and then put in 7 more. We'll give these a touch-up after trimming them. This is already feeling interesting, like some kind of abacus with these resistors rolling around. Yeah, I would love to try something like this with surface mount components. Okay, those seem reasonably straight. I'm gonna resolder them on both sides. This two-stage soldering thing where I trim it and then make it look good is a little more work, but I think it's worth it on a board like this. So now it's down to the components that need to be kind of lined up just right. So I think I just get to do that one side at a time. Because they do tend to move around, I'm gonna have to kind of keep them straight as I solder each one. All right, centered. Yeah, I mean, there are probably other ways to assemble this. I was trying not to cheat and look at photos and documentation or anything, because based on the way the kit was packaged, it seemed like that would be more fun to just figure it out. And I think I'm gonna be happy with this. You know, I didn't want parts to be like too exposed, but these transistors that are sticking out are pretty well protected by the LEDs, and the LEDs are pretty visible, and all the writing on the component side is visible. Yep, the resistors are all right where I want them. Oh, I was gonna give it a quick once over with an alcohol swab just to get some flux residue off, so let's do that before we call this completely done. These LEDs are roughly 2 volts, and this is like 150 ohm resistors. It should be safe to power this thing off of like 3 or 5 volts. Oh, let's try like 3 volts. Does that seem like a good starting point? I mean 3.3 just because that seems like something I'm likely to run this off of. And because of those pull-up resistors, all of these LEDs should light when I power this. And it looks like that's what we got. Okay, yeah, at 5 volts, each LED is drawing 20 milliamps, so that's probably the highest voltage we should set it to, but that's nice. And I think that's part of why I find these charming. Like, they're definitely not modern LEDs. They're LEDs that take me back to my childhood, which is kind of interesting. The next trick this thing should be capable of is turning the LEDs on and off by grounding these inputs. Kind of verify that the impedance is about what we'd expect. We could try grounding them through like a 100 ohm resistor. That's pretty fun. So these are all nice logic level inputs that we can hook up to other circuits when we feel like it. All right, well there it is. Boldport kit, project number 3, the Cordwood Puzzle. Fully puzzled out and cordwooded up. I think that's pretty much it for this particular kit. This does look like something that there's opportunity to come back to later by extending it, adding new bits and pieces. But as it is right now, this is the Cordwood Puzzle all puzzled out and assembled. Got our straight through wires bringing the data signals between the two boards. The kind of brown resistors are current limiting resistors for the LEDs. The blue ones are pull-up resistors for the logic inputs. And then each LED has a little matching transistor that acts as a logic switch. And then we have a little decoupling capacitor just for tradition and in case you have high-speed switching. And these little crossed wires bring power from one board to the other. The little hexagons indicate that there are 6 LEDs. That's what these are for. Have a good day and happy hacking, everyone.